The question is, find the radii. So why do I see only one answer there? $18.75 and $37.5. These are the two answers. Any questions? If you have, then let me know. And the answer is around 300 centimeters. So you are getting somewhere near that. Okay. Any questions? Let me know. If you would like me to write the equation and put the values, raise your hand. Let's see. Looks like you may have to recheck. Alright. If you would like this to be discussed on the board, then raise your hand. When we did that derivation, mu1 was not only in the object side, but it was also on the other side. Now that means that we can't use this result for this question because of the difference. So that result is not valid for this case. That result is valid if you have mu1 and mu1. They should be the same for that result to be applicable. So we go by the basics. This surface first. So for that surface, I am going to apply the general result, which is mu2 by v minus mu1 by u equal to mu2 minus mu1 by r. Now, rays traveling parallel. So u is infinity. R is plus R. So I know V now. That V will act as U for this surface. So for that surface, what is mu2? Mu3. This is final V. Maybe I can call it V dash. What is mu1? From where rays come? Mu2. What is U? V dash. Then what is mu2? Mu3. What is R? Minus R. Can you solve for V and see what you are getting? So you are getting the same answer. Fine. And if you have any questions regarding this, then let me know. B seems to be the favorite. Let me see. It is B indeed. If you would like this to be discussed, raise your hand. Magnification V by U. And we need this formula also. Convex lens, focal length plus 20. That's case 1. Case 2. It looks like a very straight problem. Any questions? Let me know. D seems to be the favorite. Let's see. Yes, D is the correct answer. Any questions? Let me know. If you need help forming equation, raise your hand. Concave lens is a diverging lens, right? I think this is also the right time to look at the cases for the two lenses that we come across most often. Concave lens. So you can see that it is diverging. Image is small but straight, and rays are not meeting on the right side. Rays exist on the right side, but they don't meet there. So we have to extend. This is virtual image. So virtual upright small image, and no matter where I take it, the object, the behavior is same. It is always virtual, upright, small. And if I take object to the left, image also goes to the left. So velocity wise, they have same direction. So only one case for concave lens, for real object, of course. Let's now make it biconvex. Now some points are important, F, then this point, beyond F, if I take it, or let me take it beyond 2F. At 2F, you will find same size, opposite. Rays are actually meeting real. So that same size case. Now if I take it on the left side, object goes further but image comes closer. Look at that velocity. And behavior wise, it is small, it is opposite, inverted, it is real. That's beyond 2F. Or let's say C, beyond C. Now if I cross this C and go towards F, at C the size is same. Beyond C, small. And towards F you will find size becoming larger and larger. Now it is larger, but opposite and real. Size is larger now. Imagine what will be the size near this, near F. And at F, it's infinity, and some inversion takes place. I mean, opposite behavior happens at F, in the neighborhood of F, just like 1090 case. 1090 if you approach from left side or from the right side. Look at that. It was on the negative y direction image. Now it is on the positive y direction. So that happens in the neighborhood of F. Again, size is huge, but now it is straight and it is virtual. Upright and virtual. It is big, upright, virtual. That's the case in this interval, pole to F case. The moment you cross F, suddenly upright becomes down, inverted. I hope it's clear. So let's get back to that problem. So here, as you saw, both are negative, U also and V also. And V is closer, U is farther. So when we say distance between them is 10 centimeter, let me ask you this question. Which is correct? Right side is plus 10. Which is correct? The upper one, the lower one? How come? U is more negative, V is less negative. When object is here, image is here. So U is more negative. This is correct. So 1, 2, 3. That should be enough. If you are still not getting 4.4, then let me know. It is actually a very simple problem. You don't even need your pen to answer this. Now, parallel rays will go to the focus. So that would be 20. Now if we want no deviation finally, then rays should become parallel again. And for rays to become parallel, this point must be the focus of this lens. So what should be the answer? Option D. Any questions? Let me know. This is your assignment question. We stop now.